I don't see it. Whatever. I'm going to trust that it is running because my little broadcast thing says so. And I will look on my second thingy-majiggy and see if I find it. Aha! So it is running. Okay. Wait, there's a live poll. Wait, that's so cool. What? Awesome. Okay. Um, let me get the link to that up and then I will share it. Actually, I can do this. This. There we go. All right, and this time I can actually see the chat because I have it open on my laptop. So this time, maybe it will be better. Guys, I'm cool. It's like a 2 PC setup, except it's a little laptop instead of an actual computer. Haha, now I can go into all of your YouTube channels now. Ha 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 ha. Now for funsies, I start a poll. Oh, Jared, no, why are you here? Okay. Wait, can I see people's... No, I can't see who puts that there. Okay, well, hi, Jared. You have, like, notifications on for me or some shit? Why are you here? You know what? Whatever. I'm ignoring you. You don't exist. Nah. Yeah. Okay, so we have to use PV-nRT here because it produces CO2 alongside the FE, the iron. So PV equals nRT, and that gives us change in volume so that we can do work is equal to negative P delta V, and the 1 atmosphere is external. So we can just say negative delta V. Then we do PV equals nRT, and then we have 1 mole and 1 atmosphere of pressure on its own, because we're assuming volume changes. We're assuming volume changes. So V is equal to RT. V is equal to, and keep in note this is R for PV equals nRT, so we use 0.08206, I think. Right? That is the right R, right? Yes. Times T, which gives us 1200 Kelvin. And then it is 0.08206 times 1200 is equal to 98.472 for the volume. But we also have to remember that this volume here is given to us in, I think, liter atmospheres, I think. Yeah. Shit, Control Z doesn't work. So to convert this from, I really need to be able to scroll through this. Yeah, liter atmospheres to kilojoules. We're gonna have to change the units. So liter atmospheres, but we want it in kilojoules, so we multiply it by the conversion, which is 1 liter atmosphere is 0.1 kilojoules. So 0.1 kilojoules over liter atmosphere. And that gives us 9.8472 kilojoules. And then if you plug into like the delta V thingamajiggy over here, that it'll be negative, but the reason why it's negative is because a negative work means that the work is being done by the system onto the surroundings. So the surroundings receive that amount of energy, which is 9.8472, and that rounds up to 10 kilojoules. So that's our right answer. I scrolled too far. Okay, for this one, it's we have to use a specific heat of water to see how much it changes in joules, and as well as the formation of this thingamajiggy up here. So we also have to remember that. So first, let's find out how much energy it took to heat up the water. So it's 500 grams and 58 Kelvin. So it's literally just 500 times 52.8 times 4.184 divided by 1000, because we want this in kilojoules because our answer's in kilojoules. So 500 times 52.8 times 4.184 divided by 1000 is 110.46 kilojoules. But that we're not there yet, because this is the energy that the system did to the water to turn it or to make it go up this amount thingamajiggy here. But we know that this reaction happened because it produced carbon monoxide, and carbon monoxide is a product here. So what I did is I just assumed, oh, okay, delta H total is literally products minus reactants, right? So I literally just plugged in, oh, delta H to make this CO, like this carbon monoxide here, is 110.46. So if I add this to here, so 110.46, in order to adjust this our new delta H, all I would do is just add to it. So it'd be 270.96, which is extremely close to this number, right? So I just assumed it was like that. And if I look at the answer key, yeah, they pretty much did it the same way, 271.96. I forgot the 1. Because when I added, I did it mentally, and I'm dumb when I do things mentally. So I'm going to append that to the bottom here. So in case anybody downloads the PDF, they don't get confused. So 110.46 plus 161.5. Awesome. All right. Sketching the plot. This is extremely easy. If we just write out the equation, it's delta G is equal to delta H minus T delta S. So if we think about this as if we write this in slope-intercept formula, it's delta G is equal to negative T S, and then minus delta H, I think. No, plus delta H. There. So if delta G, or not delta G, if T is equal to 0, then you plug in 0 here, then delta G is equal to delta H. So it's going to be 206. If we want delta G to be 0, you can pretty much solve for that, and I'm going to spare you the boring calculation, but it's 953 953 Kelvin. I don't know why I forgot the freaking thingamajiggy. Wait, add the 2 delta H in the previous problem. You add them because that's the energy it took to form this carbon monoxide here. And all I did was literally just assume products. How the delta H total for this whole reaction is products minus reactants. I was literally like, oh look, carbon monoxide's a product here, and it took 110 energy to like make that product off of this reaction here. So I was just like, oh okay. So assuming that's a product, I'm just gonna put it here. So in order to adjust this delta H for this new formation of this carbon monoxide, it's gonna be this. That logic is probably horrendously flawed, but I feel like it might be right. Yeah. Let me see if the answer key has the explanation. This is the amount of heat absorbed by the water, so that blah blah blah. Now we can find delta H for the blah blah blah. So, oh, I am right. Products minus reactants. See, and then in order the delta H is carbon monoxide is we just calculated it, and then there's the iron oxide there. So if you just isolate your thingamajiggies here like this, you end up getting that. So I was right. Although a little more flawed because it's asking for iron oxide there. So that's why I guess it's negative. But meh. Either way, same number. Okay. So graphing that, it's fairly easy. And then what is the value of the equilibrium constant K when T equals 298? We can solve for delta G through delta H minus T delta S. So if I do that now, so I plug in, here I'm going to write the equation again here so that when I save this PDF and send it out, people will not be confused. T delta S, you plug in, so delta G is equal to, okay, so delta H is in kilojoules, so remember to factor for units, minus 298 times 216 divided by 1,000. So my whole answer is in kilojoules. It will be 141.63 kilojoules. And it is positive. Yeah, it's a positive delta G. So I can plug this back into the equation. Delta G is equal to this thing, negative RT ln K. And remember, in this case, R is not the ideal gas constant, it is the other one. So delta G is equal to negative RT ln K. So, wait, I should probably make this smaller considering that I have to, actually, no, I don't care. Delta G is equal to negative RT ln K. And then if I isolate for ln K, it's going to be ln K is equal to, and then 141.63 divided by 8.314 times temperature divided by 1,000. The reason why I'm dividing by 1,000 is because R is in joules and delta G is in kilojoules. So we kind of want our units to be the same when we're doing that division. Otherwise, we're going to end up with a really funky number. And that gives me ln K is equal to negative 57.16. And we raise both of those to the both sides to the E to isolate for K. And that gives me K is equal to 1.49 times 10 to the negative 25. I ran out of space. time to write it even smaller. There, which is extremely close to this. So round up, bam. Same exact process for this. I'm not going to write down my work because literally same thing here. You know what? I'm lazy, so same exact work for the above one. There. So that can just sit there. But if I do the math, I hope you can follow along because I'm going to say it out loud. So delta H is 206 minus temperature 1100 times delta S 216 divided by 1000 to make the answer in kilojoules. Our delta G is negative 31.6. I'm going to write it here. And then if we plug it back into this equation here and divide it by negative RT, so divided by negative 8.314 times temperature again, so 1100 divided by 1000 to fix the units, we get ln of K is equal to 3.46, and then E raised to that is like 0.46 is K is equal to 31.8, which is very close to 32, which is 3.2 times 10 to the 1 first power. Yes, first power. Yeah. So that's that. And for this, we plug it into the other fancy equation, which is delta G is equal to this mess. Wait, yeah, this mess. Actually, this mess here, because Q is non-standard. So, first we calculate our delta G, like our ideal delta G, using the T delta S formula. So, and then we do RTL and Q. So, I hate having to scroll up every single time. RTL and Q. Okay, time to start plugging in numbers. First, we find our delta G, our initial delta G at 1100. Oh, look, this one's also at 1100. So I'm literally just going to steal this number because I'm extremely lazy. So delta G, negative 31.6 plus this R is the other R. So it's 8.314 temperature again. ln Q is products over reactants. So products H2.03 cubed, because remember, it's cubed, carbon monoxide 0.01 over H2O CH4, so 0.2 times 1. And if I plug this in my calculator and write out the whole long equation, also don't forget to divide this entire thing by 1000, because this is in joules and this is in kilojoules, so you want the math to work out. Plus 8.314 times 1100 divided by 1000 times ln of 0.03 cubed times 0.01 divided by 0.2. You get delta G is equal to negative 155.2, which is close enough to 155. So that's our answer. Let's look at the funny poll. Who voted no? Wow. Wow. Bullies. Bullies, bullies. Okay. I need to zoom out to do this question. Okay, so it's asking for Q1, Q2, and Q3. The way you solve for that is first you look at this, which is literally cathode minus anode. So we look, oh, Cu is probably the cathode. So we go 0.34 minus whatever the anode is. Anode is equal to E thingy. There. And pretty much solve for that. So it's 0.78 minus 0.34 is equal to negative E anode. So 0.78 minus 0.34 is 0.44 is equal to negative E anode. Get rid of the negative, and it's negative 0.44 is equal to E anode. Anode. Okay. Negative 4 is iron. So we know Q2 is iron. And then for Q1 and Q3, it's pretty obvious that it's literally just going to be the ionized form of either one, because that's how batteries work. So thing here. And then we say, oh, if you dilute both solutions so that the concentration in each becomes... Wait, is that even the right answer? I feel like that's not the right answer. Am I trolling? Oh, it is the right answer. Okay. Remember that this equation exists here. This one. So E is equal to E minus RT over NF ln Q. And Q is products minus reactants, excluding solids. Because both Cu and Fe are 2 electrons, so that they're both going to have the same coefficient in their reaction, we can instantly tell that Q is going to be equal to 1 when both of them become 0.5. So E minus RT and F blah, 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 it's literally going to become E minus 0. So it's just going to stay the same. Note that this will not work if the amount of electrons each of them generate are different. Like say if it was, instead of Cu, it's Ag, because then F, you're going to require 2 Ag instead of just 1 Cu, and because of their concentrations being different and the coefficients, because the coefficients in Q are required, you're going to have, I think, if Ag is the cathode, yeah, you're just going to end up with a different number than 1. Okay. Using your knowledge of chemical bonding, which molecule would you expect to have the most negative energy of formation, delta HF? Not this, not this, immediately, because they're both in their respective elemental states, and we know they're stable, because every time you take a breath, both of those go into your lungs, right? And for CH4, we can tell that remember how when we did that little thingamajiggy with calculating delta HF off of the individual bond energies, and you had to add them all up? The bonds between CH are probably going to be weaker than OH, because remember, OH is a hydrogen bond as well. So, and in addition, that there's probably more bonds here as well, because there's what, 1, 2, 3, 4, 5 atoms in here instead of the 4, or 5 and then 6 here, because I can't fucking count. This is 6, so this one's probably going to be a more negative enthalpy of formation, because there's more bonds in here that it needs, so it's probably this one. And for this one, I typed out a little explanation. Yes, you are sleepy, so am I typed out like a little explanation, but basically, if you think of it as W is equal to, no, not W. There's a formula for this all the way up here. Delta E is equal to Q plus W. Why the hell did I write K? I'm tired. Q plus W. Eric, you're here too? Oh my goodness. Pretty much Q is the energy it takes to heat something. W is a work that thing does. W is written as negative P, external P, by the way, delta V. If you hold pressure constant and volume changes, this number is gonna be a negative number, right? Which means that it's gonna steal some energy away from Q to expand the volume. And if that happens, not all of the kilojoules of heat here are going to be used to purely raise the temperature. Instead, some of it's going to be used to expand the volume. So if pressure is constant and it's delta V and we let it expand completely, I think all of the energy is probably going to go into expanding it rather than, not all of it, because there's some dissipation obviously, but some of it's going to be spent. So the final temperature of the system may or may not be higher, but it's less consistent. If volume is held constant, delta V is equal to 0. So work equals 0. So delta E is equal to Q. All of the energy is going to be spent heating up the system. So the temperature is just going to be higher that way. Okay. This problem. You have made a battery about a blah, 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 blah. If overall reaction has delta G, what will E cell be? First off, you can probably do this by using an equation that uses delta G and E cell. So let's look for one. Oh, look, delta G is equal to negative NFE. Wow. So if we isolate for E, where the hell did I? Oh, there we go. If we isolate for E, it's going to be delta G over negative and F, and you plug it. So negative 228 divided by negative 3 times E. Negative 3 times 96485. Oh, don't forget to divide the denominator by 1,000 as well, because I believe F is in, Celsius per mole thingamajiggy, and it is very annoying, I think. Wait, do you have to divide by 1,000? Either way, if you divide by 1,000, it's probably such a big change that... Oh, you do have to divide by 1,000. Okay, good. Yeah, you had to divide because you get like a weird joule energy in the denominator for some reason. So, I mean, if you didn't divide the denominator by like 1,000, you're gonna get a really, really tiny number, I think. Yeah, you get something times 10 to the negative 4, which is obviously not one of the answer choices. So it covers that mistake for you. But just as divide by 1,000, because that gives you 0.79. More specifically, E is equal to 0.787, but that's close enough. Stream val, it's more interesting. Bruh. Man, I literally, before doing this, I got out of my intramural val game for the thing. Yes, I won. I top fragged. Submit my assignment 1. Okay. That is not the right server. Is this the last problem? Oh, it is. Okay. Well, delta G doesn't always indicate whether or not a reaction is exothermic. Because for delta G to be positive or negative, it's going to be delta G equals delta H minus T delta S. There are two ways, or there are multiple ways for delta G to be negative, which is when delta H, in order for delta G to be positive or negative, delta H can be either positive or negative as well. It literally just depends on delta H. So for example, an exothermic reaction is, I think, when it was a negative delta H, but there is a way for delta G to be negative or positive, and that's depending on how big delta S is. Yeah. So delta G won't always tell us whether or not it's exothermic or not. Same thing for vapor pressure, because if we look at this equation here and also this equation, when you plug in, we can't always tell ln of Q or if it's just K or not, right? By just looking at the number, we can't tell if it's at standard or non-standard, because that's just something that's given most of the time. So we can't always tell whether or not what the vapor pressure of everything's going to be. And then for what the entropy change of the universe is, I honestly didn't really pay attention to that. I just did process of elimination, but we can look at what they say in the answer key. Let's see. We don't have to calculate both delta S system or delta H surroundings to figure out if delta, which is required for this process to be spontaneous. Rather, we know delta G. We also know delta S without having to calculate. It can be tricky. I have no idea what that means. I have no idea how to calculate. I have no idea what they're saying here. Wait. How to calculate delta S universe from Gibbs free energy. Let's see. It's not here. I said all videos, bro. I don't want to get hit with the copyright strike. I think 90% of my videos have a con. Delta G is just a measure of a way of measuring favorability. Yeah. Oh, okay. So if we know delta G, we can know delta S, because whether or not it's favorable. Interesting. Okay. Well, yeah, that's the first midterm. Do I want to go over the second one, or am I going to pass out before? Did I even finish the second one? No, I did not. Oh God. What the hell? Why is it so long? Oh my God. Yeah, I'm doing this tomorrow. Hell no. Okay, well, that's I think I'm done for the day. Or I guess it's already Thursday, but I will resume this thing tomorrow. Maybe at like, what time do I want to wake up tomorrow? I want to wake up early. I want breakfast. Wait, what's the menu tomorrow? Is it worth it to wake up early for breakfast? Let's see. Foothill. No, it's not. They don't have pancakes. I will probably try to wake up at around 7 to 9 ish, and then I will probably do this stream tomorrow at 10 for the rest of the midterm. It will probably be longer because I'm going to have to um I'm gonna have to actually try solving the rest of the midterm myself because I have not done the rest yet, so I'm gonna have to figure that out. But yeah, you have class till 11, bro. I have class from like 2 to 5, so and I have not studied at all for my math quiz. But then again, the quizzes aren't weighted much, so. But yeah. I will see you all tomorrow, and maybe I will be at Moffat before or after. But it is very cumbersome for me to stream at Moffat because I can't really bring all my streaming shit. So, good night, everybody.